All right, a couple more kind of key problems here as we're looking into quiz day today. So this one says you have an aquarium and this is its volume. Okay. Use factoring to determine possible expressions for the dimensions of the tank. So for the aquarium, we're expecting kind of your typical rectangular prism type aquarium, one that would look something like that. So it's going to have a length, a width, and a height. So really what we got to do is if we can get this into factored form, which is all the problem really says to do is use factoring. And if we get it into factored form, then those sets of factors are going to be the different possible length, width, and height of this box. This is for aquarium in this case. So right away, there's an easy GCF of just x. So we pull that x out, leaves us with x squared minus 6x plus 8. And then we look at this quadratic and we say, okay, can we factor this? Well, are there factors of 8 that add to negative 6? Yes, there are. You could use negative 4 and negative 2 because those would multiply to be positive 8 and they'd add to negative 6. So at this point, we write this in fully factored form. And basically, we're done at this point. When it says, what are the possible dimensions of the tank? It could be x by x minus 4 by x minus 2. So these are like the length, the width, and the height of a possible box. And you could do those in any order. You could call this the length, and this the width, and this the height if you wanted to. That part doesn't matter because you could just turn it one way or the other. But that's the idea. This is really just a factoring problem. So don't overthink problems that are actually pretty easy, like this one. This one says, what are the real and complex zeros of this? So this is actually fairly similar. So when we start this problem off, if we want to find the zeros, we want to factor it. So once again, I'm going to go ahead and pull this GCF out. So this is kind of a lot like the previous problem. And that's going to get me to here. Now I'm going to say, does 8 have any factors that add to negative 4? So you can use 1 and 8. That's not going to work. You can use 2 and 4. And that isn't going to work in any sort of way. And so at this point, I'm basically looking at, all right, I know for sure this has a 0 at 0. So when I'm talking about what are my solutions, x equals 0 is definitely one answer. But this one I can't factor. So what that leads me to believe is this is probably going to be too imaginary. Or as this problem calls them, complex. So same thing, different word. So in this case, I did graph this just to kind of double check things. So I took the original problem and I threw it in my calculator and I saw that it crossed at 0 like I expected, but then it didn't cross again. Another just indicator that, we're looking at probably two imaginary solutions here. So how do we find our imaginary solutions? We use the quadratic formula. Anytime we hit a problem that's a quadratic that we cannot factor, we go quadratic formula. So opposite of b, which would be positive 4, plus or minus b squared minus 4ac, all over to a. So if we simplify this, we're probably going to get imaginary values, and we'll be able to give our last two solutions. All right, so under my root, I'm going to have 16 minus 32. And 16 minus 32 is negative 16. So definitely going to get imaginaries here because I'm square rooting a negative value. So what's this going to be? Well, the square root of negative 16 would be 4i. Because the square root of positive 16 would be 4. So if you're taking the square root of the negative, it's just going to be the same thing but imaginary. So now we're looking at this. And just to simplify this further, these numbers do both divide by 2. So 4 divided by 2 is 2. 4 divided by 2 is 2 again. And so that is going to be my other two solutions. So when I'm given my answers, I would say this is the 3 solutions to this problem. And again, just a reminder, whatever the degree of the problem is how many solutions you should have. So because this third degree, I know I'm not done until I've found 3 solutions. One real one, and then this would represent my 2 imaginaries because the plus and the minus. So that's that. Good luck with that quiz today.